you know that whenever you write down a word, you are using a code? Every language is a set of symbols, sounds, letters, words that represent something, that have meanings. It is probably easier to think of algebra as a code system because you are not as familiar with the meanings of its symbols. It's a special language with its own signs and symbols to express meanings. Pop quiz! Which word in English has the same meaning as which symbol in algebra? In other words, how do we translate from English into algebra? In this module, we'll find out. In fact, we'll look at two different kinds of translation. The first will be called just that, translation, from English to algebra. The second kind is quite different. We call it evaluation, and we'll meet it later. Let's look at some of the words in English that go with key symbols in algebra. They're simple enough, except that each meaning in algebra can be said several ways in English. For example, add, plus, and sum of all mean the same thing, and we use only one symbol in algebra, the plus sign. Take a moment to look over the other common symbols. Let's try translating some words into symbols. We can start with something easy. Find the sum of this and that. Add all of these to all of those. What is this plus that? A plus sign, an X and a Y does it all. We use two different letters because there's no indication that the two numbers are the same. But in algebra, we change the order slightly and write X plus Y. Now this one is a little bit harder. Let's read it. 3 times a number minus the square of another number. First, rewrite the pieces in the language of algebra. There are two different numbers, so we use two different letters, A and B. Now we write our translation. 3 times a number, 3a, minus the square of another number, b squared. This statement in algebra follows the same order as the English statement. But quite often, English follows one order and algebra another. You can't just write it out in English order. It won't make sense. Instead, you have to think of the problem in pieces and write it out that way. What are the pieces? Well, the word quotient tells us that one thing is going to be divided by another. What's going to be divided? The sum of a certain number plus 5. That's one piece. What's it going to be divided by? The cube of that same number. To represent the number, we use an X, or any other letter you prefer. The number plus 5 is written X plus 5. Now, it's divided by the same letter, X, cubed. We write it all out in either of the two optional ways that show division. Notice that when we do a translation, we first decide what basic process we're being asked for. Is it a quotient? It's division. Is it a product? It's multiplication. Or is it a difference or a sum? Then we know what parts to look for. We find the parts, put them in the proper sequence for algebra, and we've got it. Here's one for you to try. Remember, identify the basic operation, find the parts, arrange them for algebra instead of English, and you've got it. Pause the player, write out your answer, and we'll compare notes when you're done. The key word in our example is product. This means we will be doing a problem in multiplication. Something times something else. What's the something? Easy. It's the second line, the sum of the squares of two numbers. What's the something else? The bottom line, the sum of the same two numbers. So let's now write out each part with algebra symbols. For the first part, we represent the two numbers with an X and a Y, and they're squared and added together. In the second part, we want the same two numbers, so they are X and Y again. We want them added. We want the product of the first part and the second part, so we multiply one by the other. To get the final answer, do we have to use X and Y for unknown numbers? No. Our choice of letters is arbitrary. You could have used any other letters in place of X and Y without affecting the answer at all. Sometimes we translate whole sentences rather than just pieces. For example, 2 times one number plus 3 times another number is 8. Sometimes it's a big help to rewrite the English problem first to see if you can find the pieces. That should help you find the answer, the right algebra translation. Remember our list. We translate is into the equal symbol. Being able to break a sentence into key parts is going to be a big help later whenever we need to translate a problem into algebra and then solve it. Here's an example. If the sum of Carlos's and Mary's age is 33 and Carlos is twice as old as Mary, we can write C plus M equals 33 and C equals 2M. And that gives us a way of figuring out that Carlos is 22 and Mary is 11. How? We'll see that in another module when we study equations. Here we just want to practice the first step. Start by translating the English into algebra. Now take a look at some more examples in your textbook until you feel comfortable with this kind of translating. And then work some of the problems to be sure that you do come up with the right answers. This kind of translation has to be exact. The message in algebra has to be the same as the message in English. It's time to consider the other kind of translation we mentioned in this tutorial, the kind we call evaluation. It doesn't go from English into algebra, it goes from letters into numbers, or what we call values. We use it when we give a letter a number value and then solve the expression to get a final number answer. Look at this example. Suppose we arbitrarily give x a value of 3. Evaluating it that way, we get a final answer of 9. Evaluating x differently, translating x into a different number, say 4, gives us a different answer. Evaluation is also called substitution. We give x a value of 4, or we substitute 4 for x. Substitution, or evaluation, can be very simple like this, or it can get more complicated, but the steps you follow are the same. In this example, let's give y a value of -1, or we can say substitute -1 wherever we see y. They both mean the same thing. Y squared becomes -1 squared. 2y becomes 2 times -1. The final one remains unchanged, and the result, the answer, is 0. That value for y was arbitrary. If we chose another value, it gives us a different problem entirely, with a different answer. Now y is 3. So y squared is 3 squared, or 9. 2y is 2 times 3, or 6, and our answer for this substitution is 16. As the problems become more complicated, it's very important that we perform the operations in exactly the right order. Remember our recipe from Module 2? If we don't, we're going to get strange and wrong answers. So we have to do the brackets or parentheses first, working your way out from the innermost brackets. Then the exponents, if there are any. Then multiply or divide before we add or subtract. And finally, work left to right. Let's see how that works out in this problem. For every x, we're substituting a -2. We move to the inside bracket first and substitute -2 for x. Then we do the same with the x in the outer bracket. If we're very careful about our parentheses, it will come out looking like this. Then we're ready to attack the inside bracket where -2 minus 1 gives us -3. Now we still have two operations to do inside the outer bracket: subtraction and multiplication. Multiplication comes before subtraction. -3 times -3 gives us a positive answer, 9. And we're ready to finish up inside the outermost bracket. -2 plus 9 is 7. Where do we go from there? Once again, we multiply first, before we subtract, and then the subtraction gives us our final answer, negative 13. Are you wondering why we move more or less from right to left as we solve this problem? Didn't we break the last rule, which tells us to work from left to right? We didn't, because that is the last rule, and first we had to do all the other operations wherever we found them. When other steps in the recipe are done, and we have to add or subtract 2 or 3 times in a row, for example, we will do it from left to right. You'll need some more examples of this kind of thing, and you'll find plenty of them in your textbook. For practice, take a look at this one. And just to make it interesting, we'll substitute for 2 letters instead of 1. Give x a value of 3, and give y a value of negative 4. Don't panic. By systematically working step by step in the right order, you'll get the answer. Pause the player, and when you're ready, we'll work through it together. Let's see what we get. Our first step is to do all the substitutions. 3 for every x, and negative 4 for every y. Then we move inside the brackets and simplify. 2 minus negative 4 is 6. Remember, we'll want to multiply before we add and subtract. So negative 3 times 6 is negative 18, and 3 times negative 4 is negative 12. We finish by subtracting from left to right, and we have a negative 27. The time to get in more practice is right now. Try some examples from your textbook. Keep doing them until you're sure you know exactly how to go about it. It isn't hard, but you have to be absolutely systematic. Is evaluation starting to make sense? It's not too hard if you follow these steps. First, substitute for the variables, the letters, one by one, and then work on each part of the problem in the proper order, following the recipe you learned in Module 2. Right now, you might want to notice something important about this module. We looked at 2 very different operations. The first was translation, from English into algebra. The second was substitution, or evaluation, giving an arbitrary value to each of the letters or variables in a problem. But why do we bother with all this? Because translation and substitution are going to make things a whole lot easier for us when we start using algebra to solve real problems, the kind of problems that algebra was invented to solve in the first place. Do your practice now, and you'll be ready then. Good luck!